This is the solution to the first problem on the packet. So the first part on question number 1, we're looking for the x-coordinate of the position of the particle at time t equals 2. We're finding x of 2 equals 3 plus the integral from 1 to 2 of cosine of t squared. Because cosine is the x-coordinate, and we're figuring out where position-wise, which is where do I start? 3 on the x, the point is at 3, 5, and how far have I gone? How far have I gone? That's integrating from 1 to 2. Our answer is 2.557. Part B. Between t, 0, and 1, there is a point on the curve at which the line tangent to the curve has a slope of 2. At what time is the object at that point? We need to find where the slope is equal to 2, at what time t. Derivative dy dx equals, it's a parametric equation, dy dt over dx dt the derivative of y over the derivative of x is what we'll need to find. We're given the velocity vector. The velocity is the derivative of position. The question is asking for a point on the curve. The curve is the position function. Since they already give us the velocity, which velocity again is the derivative of position, it's just what's given. E to the 0.5t over cosine t squared. We will need to figure out where does this equal to, for what value t. So all you have to do is put this in the calculator, put this into y1. You can use, again, the calculator doesn't care if you're in parametric, or I would put this in regular function mode and use x in place of t. Find the intersection, so this would be in y1, the e to the 0.5t over cosine t squared. Put 2 in y2, calculate intersection, and you get t equals 0.840. Part C. Speed. Find the time at which the speed of the particle is 3, so when it equals 3. Speed, we know, is, according to the definitions I gave you in the formulas, the square root of dx dt squared plus dy dt squared. So that would be, its speed is magnitude. So speed equals the cosine of t squared, quantity squared, plus e to the 0.5 t quantity squared. We want to find out where does that equal 3. So once again, you can put the left side in y1, put the right side in y2, calculate intersection, and we get t equals 2.196, and that part is done. For these questions, it's really learning the formulas I gave you and then just plugging them into formulas. Part D, find the total distance traveled. Total distance traveled in parametric is the integral from the, in this case, 0 to 1, the time, and then it's the square root of the dx dt squared plus dy dt squared. Part D, distance traveled, distance equals the integral from 0 to 1, and it's cosine of t square root of cosine of t squared squared plus e to the 0.5t squared, which is the same as if you want to eliminate the 1/2 or 0.5 in the square to just be e to the t dt. Punch that in the calculator, we get 1.595. Question 2. Is the horizontal movement of the particle to the left or to the right at time 2? Explain your answer. Find the slope of the path of the particle at time t equals 2. Horizontal is x, so we want to find for part A dx dt at time 2. So if we plug in 2, we would get square root of 2, oops, not t, sorry, 2 for t plus 2 over e to the second. Square root of 4 is 2, so t over e squared. Because dx dt at 2 is positive or greater than 0, the particle would be moving to the right at time t equals 2. Find the slope of the path of the particle at time t equals 2. Slope dy dx equals dy dt over dx dt. We're evaluating that at t equals 2. So you're just going to plug in 2 for dy dt, sine of 2 squared, and then dx dt is going to be what we just solved. We just got that answer. It's 2 over e squared. Put that in the calculator, you get 3.055. Part B. Find the x-coordinate of the particle's position at time t equals 4. X of 4. Starting point was at 1, 5. X is 1, so 1 plus. How far did we travel? So we're going from 2 to 4, because we started at 2, going to 4 for time. And then we have the square root of, for x, t plus 2 over e to the t dt. Put that in the calculator, 1.253. Part C. Find the speed of the particle at time t equals 4. Find the acceleration vector of the particle at 4. So speed, again, is equal to the derivative at 4, so dx dt squared plus dy dt squared at 4. So that speed is our magnitude. They already gave us those values, so we just have to plug them in at 4. So find the speed of the particle at time t equals 4. So again, I'm just going to show some shorter notation. We take the derivative of x, which is dx dt squared, at 4 plus derivative of y dy dt squared at 4. You can use y prime for these. It's just shorter notation. If you want to use dx dt dy dt, you can. Plug it in the calculator, you get 0.575. So again, this is dx dt, this is dy dt, which is given to you in the original problem. Acceleration for part C is the derivative of velocity. So we want to just find the slope or the derivative at 4. So you can just use n deriv of the dx dt and n deriv of dy dt. So the function for dx dt was square root of t plus 2 over e to the t. The function for dy dt was sine squared t. Using f and I and t, we plug them in the calculator to give, using n deriv, we plug them in the calculator. We get negative 0.041 and 0.989. Part D, find the total distance traveled by the particle from t equals 2 to t equals 4. Distance is, by definition for parametric, equal to the integral from 2 to 4, the square root of dx dt squared plus dy dt squared. Again, you're just going to plug in the functions for dx dt and dy dt. Our answer, 0.651. I would like you to try the third problem in that packet. Have a great evening.